Every time you put food in your mouth, you set your body's defences onto high alert. And anything that makes it past those defences is entering a biological food processor. Will you stop that? Now, this happens every time you eat. And normally, you don't even think about it. But that changes tonight, because
Tonight, we're heading down the tube. Oh, dear.
that, can I get rid of that? Welcome to the Christmas lectures from the Royal Institution, supported by CGI. I'm Chris Van Tulleken, and I'm going to be showing you why food matters. It matters because it's what we build ourselves from, and it matters as our fuel. But I'm also going to be demonstrating how, when one ape started to process food outside its body, it changed everything, from our anatomy and physiology to our culture, and everything about the surface of planet Earth as well. Now, today we're going on a short journey. It's just 7 meters long, and you can see that journey here on this perfect, accurate representation of me. This is what I look like without my clothes or my skin. As you can see, it's all muscle under the shirt. And we're starting in my mouth, and we're going to the other end, via the esophagus, the stomach, the duodenum, the jejunum, the ileum. Then we get into the colon, the ascending colon, the transverse colon, the descending colon, into the rectum and out the other end. And this tract, this gastrointestinal tract, is where our food is broken down and then absorbed and, of course, transformed. We are going to need a few gross alerts along the way. Now, eating is a hazardous business, because you will all know one of the first things you learn in biology is that a central project of all life is to keep the outside outside and the inside inside, not to get them mixed up. So putting things inside the tube is risky. It comes with the risk of microbes, pathogens, toxins, and so the entrance to our gastrointestinal tract is extremely tightly guarded. And the defenses begin when you even just start thinking about food. So I want you all to think about eating something really sour, like a lemon. Now, can you feel the saliva pooling inside your mouth as you think about eating this acidic food? To help us now explore the defenses that are at the beginning of the tube, all of them, I want you to welcome Associate Professor in Public Health at University College London, and of course my identical twin brother, Dr. Zand Van Tulleken. I said to come dressed as a lemon. Can we?
That was all they had.
Can we start by having a look in your mouth using the special rhinolaryngoscope that you're skilled at using? Now, provided you have at least 6 years of postgraduate medical training and a rhinolaryngoscope, you can do it at home. Now, what Zand is going to do, Zand, can you just demonstrate? I'm going to hold this here, trying not to touch the end. Endoscopes, of which this is one, are fibre optic cameras that doctors and other clinicians can use to look inside your body. We can put them up the back passage, we can put them down your throat, but this is a very, which we're not going to, well, maybe we will. Let's not give any spoilers. And if you see there's a light on the end of it, and Zand has a controller so he can move the end to look around corners in the body. And the first thing we're going to do is have a look in Zand's mouth. The first thing you see are the lips. Lips are incredibly sensitive. You can detect lots of toxins. Just get on with it, Zand. Put it in your mouth. So as we go into Zahn's mouth, we can see at the back of the mouth 2 white scars from where Zahn had his tonsils out. The dangly bit is the uvula. And let's have a look now at the surface of your tongue. Put it right down. Yeah, nice. That's a lovely view. Now you can see the buds on Zahn's tongue. What are those buds? Do any of you know? Taste buds. They are not taste buds. They are papillae. Now, your taste buds are inside your papillae. Your papillae are buds, your taste buds aren't buds. They're more like little pits. They're so small you can't see them, and they're collections of very specialist cells. So it's a bit confusing, but the papillae, all the rough lumps and bumps, that is where we find the taste buds, okay? And your taste buds are sensors that detect the chemical properties of your food. And they send information to your brain, and then you can decide whether you want to receive it, swallow it, or if you want to reject it. Now, your mouth is also a chemical factory. And Zahn, I want to put in, I'm going to let you pick your tomato.
Oh, you bet. Okay.
Maybe a small one. Now, I want to show you first, but don't chew it just yet. Okay, so we've got the tomato in the mouth. Now you can see, I want you to see this perfect sphere at the back of Zahn's mouth. This is potentially covered, it might be full of poisons. Not all red berries are safe. So Zahn, I want you to move it over to your molars, bring it to the side of your mouth, and we're going to see if we can film Zahn with the first stage of breaking down food, the mechanical destruction of food. Because your body destroys food in 2 ways, mechanically and chemically. And here we go. So Zahn's going to apply pressure. There we go. Very skillfully not biting his tongue. He's mixing it with...
the endoscope.
Or the endoscope. Don't bite the endoscope. That's the main thing. We cannot afford to buy a new one. He's mixing it with saliva. Now, you make 1.5 liters of saliva every day. You make about this much. You're swallowing it constantly. And saliva is amazing stuff. So whilst he's mixing the tomato with the saliva, it's going to lubricate the tomato. It's full of chemicals called mucins, which make it slippery and slimy. It's going to clean the tomato. It's got chemicals and antibodies to kill pathogens, microbes. It's also got enzymes that start digesting the food in your mouth. They break down starches and fats, amylases and lipases. And finally, it's got chemicals that neutralize the acids in the tomato so that they don't damage Zahn's teeth. And Zahn, I think you are now ready. There we go. Dismantled, partly digested tomato. Zahn, big round of applause. Thanks very much. Give it a swallow. So salivation is just one of the responses that our bodies make in order to prepare us to receive food. There are all kinds of other physiological changes that happen when you smell food, you think about food, you see food, or you interact with food in any way. But what if the food on our plate doesn't match our expectation of what we've been led to believe it is? Well, to help us explain that, I want to invite national treasure, legendary chef, and judge on the Great British Bake Off, Dame Prue Leith. Are you there, Prue? Oh. How are you doing? This is very good, because you've prepared us a bit of Christmas dinner here, haven't you?
Ah, well, it's Christmas.
It's the Christmas lectures.
This is turkey.
You've got some a standard turkey dinner.
Turkey veg spuds.
Great, OK. Tell me about food appearance. Is it important, or do you just have to get all the flavour right?
Well, the flavour's important, but I tell you what, chefs always say you eat with your eyes, because they know perfectly well that if you don't like the look of food, you won't try it. So I do think that chefs are... Sometimes they're obsessed with the way food looks, and they overdo it and forget that flavour actually matters more.
But we have to get past that.
Yeah.
Probably the first line of defence is smell, and the second is going to be sight.
Absolutely.
You've got to get past
Absolutely.
these defences at the entrance to the tube. OK, shall I reveal?
This is a sort of classic turkey dinner.
And you've got some gravy?
We need a bit of gravy.
You're going to put a splash of gravy on it?
Yeah, a bit of gravy on it.
Now, can I get a volunteer? I'm going to take you just because you're on the end. Come on down. What's your name? Zavi. Zavi. Come on down, Zavi. Big round of applause for Zavi. Come in the middle. Xavi, are you up for trying a bit of Prue Leith Christmas dinner?
Yes, definitely.
Brilliant stuff. OK, actually, we're going to get Xavi to try this one. Is that right,
Yeah,
Prue?
this one, yes. This one I've doctored a bit.
You've doctored a little bit. OK.
Yeah, doctored a bit.
Xavi, this is the meal we want you to try, or contemplate trying, OK? There we go. Now, a little bit of wincing from around the room. Doesn't look quite right, Prue, I've got to say.
Well,
Are these potatoes that are blood red?
Yes, they're potatoes, and that's turkey, and that's carrots.
The
and
black
that's
stuff is
sprout.
carrots.
And the brown stuff is sprouts, and the bright green stuff is turkey.
OK, you like, Xavi, you like turkey?
Yes.
There you go, there's a knife and fork.
Are you brave enough to try that?
I would definitely rather eat.
You'd rather eat that. OK, why don't you try the green stuff anyway? So Xavi's a bit disgusted, but he is able to overcome that sense of disgust using other bits of his brain. Well, I think he is. Are you going to be able to do it? Go on. How is it? It's OK. What does it taste like?
It tastes like turkey.
Turkey and gravy, right. Once you get past the eyes, the fact that Prue has coloured the turkey bright green is neither here nor there, but it really, really puts you off, doesn't it? OK, Prue, do you want to do a bit of gravy on the veg and see if Xavi
Yeah,
wants
I've got
to
a bit
try
of gravy on the veg.
maybe a
So we'll
sprout?
put a bit more. I want you to taste... Can I just pick up this carrot and put it in your mouth? Would that be all right? Open wide.
Excuse fingers. Xavi, what do you make of that?
It's very sweet.
It's very sweet. Is it a carrot?
No.
What is it, Prue? What have you done?
It's cake.
It's cake. Is it all cake?
That's cake, and this is cake. Look.
Oh, the sprouts are cake too. Oh, they're very convincing. Can I try a Prue Leith cake sprout? Is it sprout flavoured?
No, it's very sweet.
Hold on, let's cut one in half. I
cake.
just want to have a look. Just want to show the camera how beautiful these are, the little leaves. But if we cut them in half, Xavi, do you want half a sprout? The only slightly discomforting thing is that they are covered in savoury gravy, which is not really what you're expecting.
And
There you
this
go.
sort of pink cake.
So food exists on a knife edge between desire and disgust, and you can flick quite quickly between those two states. Prue and Xavi, thank you very much for being such a good sport. You can head back to your seat. So, tiny alterations in our ideas about food or in the food ourselves can shift them from being desirable to disgusting. So, we are going to investigate, do we learn to be disgusted, or is it something that we're born with? And to help me with this, I've enlisted a real expert. She would be with us today, but it is well past her bedtime. So instead, we filmed her earlier today in the RA. This is my baby daughter, Indigo, and she is 9 months old. We can see her there. And Indigo is great for doing this experiment with because she's hardly tried any foods ever. So we're going to put some foods that you would all be disgusted by, that none of you would want to eat, and see if she has an inbuilt sense of disgust. So the first thing we're going to try is some live earthworms in dirt. So there we go, that's my wife Dinah. We've got two very severe RI scientists standing behind her collecting the data. And so Indigo, no sign of disgust. She's not pulling a face, she's not distressed. She's enthusiastically engaging with the worms. She's picking them up. Now the question is she gonna put one in her mouth? She's definitely not disgusted. Now, we did do another experiment where we gave her a hospital bowl with a very convincing large human poo in it. Now, of course, this is a cake made of dates, doesn't smell bad, but she has no aversive reaction at all. She's got no intellectual knowledge about poo, about pathogens, about infection. To build up the memories of food that allow us to desire them or be disgusted by them, for the most part, we need to experience them, and we need to use our senses, and particularly our sense of taste. There are some smells that we seem to have an inbuilt dislike of, even if we can learn to love them eventually, and there are some tastes that we don't like as well. So now, for the next demonstration, I want to have a volunteer with a sense of taste. There's a young person there in a blue top. Yes, you. Round of applause. That's good. Give a wave. Now, what's your name?
Abel.
Abel. Great to meet you, Abel. Come here. Are you happy to try some stuff? We're going to go through the 5 tastes, OK? The 5 common tastes. There's no tricks here. I just want you to tell me what you're tasting. OK, stick your tongue out. I'm going to put it carefully on your tongue. That's good. Don't let it fall on your top. How's that?
Salty.
I mean, it's very salty. Was that not too salty for you?
No, not that salty.
You didn't mind it. OK, it's very interesting. People experience tastes in very different ways. So for me, that was almost as salty as seawater. For Abel, that was just fine. OK. And salt taste, let's have a go at that.
Kind of sweet.
Kind of sweet?
Yeah, it's not very sweet, but kind of sweet.
Not very sweet. It's have another go. I didn't touch my tongue. I'm being careful. No double dipping here.
Yeah.
It's sweet, isn't it? That's sweet taste. So salt, very, very important to get your salt taste right. Too much salt, you die. Too little salt, you also die. Salt is one of the molecules that keeps you alive. Sweet, was it nicer than the salt or about the same?
I mean, I have a sweet tooth, so I'd say this sweet liquid was.
Did you love the sweet liquid?
Not love, but I liked it. Yeah.
It was fine. Okay, good. Okay, try this one now. Tongue right out. Okay, see what you make of this one. Lean back a bit. Open your mouth up. I'm gonna get it on your top. There you go.
Oh, that's sour. Yeah, that's sour. Oh,
How would you describe that?
extremely sour.
Sour. Very good. So do you know what sourness is? It's acidity. That's what you're measuring. You're checking the pH of a food. Now, almost all animals hate sourness, but humans are one of the few that like it, and it's probably because we need vitamin C in our diet, and vitamin C is a sorbic acid, so it gives us a sense that the acids can be quite nice. And it's not that unpleasant, is it? It's sour, but it's somewhat refreshing.
It's not unbearable.
Stick your tongue out, Abel. That's very good. Now, get that right to the back of your tongue. Now, how was that? Hold on, I feel like I better have something. This is the one I was dodging. And particularly if you get it at the back of your mouth, it's very bad at the back of your mouth.
Yeah.
So this is denatonium benzoate. Okay, it's intensely bitter. It's probably the most bitter molecule known, and you can detect 5 molecules of this in 100 million other molecules, okay, in 100 million parts of water. You have a huge number of bitter receptors in your mouth. Toxins are classically bitter. Caffeine, quinine, lots of medicines, very, very bitter. So that's a line of defense, is the bitterness. Now, this is the 5th one. We've done salt, sweet, sour, bitter. Do you know the 5th one?
Umami?
Umami, amazing. This is a Royal Institution audience. Of course you knew it was umami. Stick your tongue out and tell me what this tastes of. So this is monosodium glutamate. And there are a few different molecules that can be put together to give you umami, which is savoury flavour. Are you getting that?
Yeah, I'm getting a hint of savoury, yes.
Okay, now look, let's mix together a splash of all these. Let's add a little bit of bitterness, not too much. Okay, pour in some of that. I'll add a bit of the salt, bit of sweet, pour in some umami, bit of sour here. Now have a swig of that and see what you make of that. You're very up for this, Abel. Is it nice?
No, it tastes like vinegar.
It just tastes sort of bad, doesn't it? People think there are maybe other tastes as well. So there might be an oily taste. You might be able to taste calcium. You might be able to taste some starches. So other tastes may emerge. But I can tell you what, Abel and I, we could stand here all evening fiddling around with this. We would never make anything delicious because something crucial is missing. And I'm going to do an experiment and show you what. But in the meantime, big round of applause for Abel. Great work. So we talk about delicious taste, but actually when we isolate those tastes or mix them together, it doesn't quite work. Now, you have all been given nose pegs, I believe. Could you now put on your nose pegs? Great work. Is it on tightly? These are professional grade nose pegs. Now, the demo team are going to hand out little beans to all of you. They're going to pass them on. So take just one bean and don't do anything with it yet. Just hold it in your hand. Pass them on as quick as you can. And no one's eating their bean yet. And police the people around you. Okay, so everyone's got their nose pegs on now. Okay, and I'm going to do this with my fingers. Keep your nose pegs on. Take a breath.
put the bean in your mouth and chew and keep the nose pegs on. You won't be tasting much of anything. When I say, on the count of 3, you're going to take the nose pegs off. 1, 2, 3.
You will all just have experienced a burst of flavour. And say the name of the fruit you can taste together now. No, these are banana-flavoured jelly beans. That was just underlining Prue Leith's point earlier that we eat with our eyes. The point is, you all experienced a burst of taste when you took the nose pegs off, didn't you? There was a change in the room. So what was going on? Taste, in simple scientific terms, is what happens in your mouth. When you took the nose peg off, what you experienced was flavour. And flavour, that banana flavour that you all thought was pear, the banana flavour is smell. But where exactly are you smelling it? Are molecules coming out your mouth and going up your nose? To show you, can we bring back on Associate Professor of Public Health at University College London and my twin brother, Dr. Zahn. And you've really dressed for dinner. Okay, good. Right. Well, we have a meal.
I'm a little hungry now.
We have a meal. Yeah, we have a meal coming up. Great. So Zahn is now, use the endoscope. Zahn's now going to show you a view of the human body that is extremely difficult to get if you aren't the patient. In order to understand what we're looking at, to show you the anatomy, I have here a real human skull. This is a skull from someone who died more than 100 years ago. They were a woman. We don't know much else about them. But skulls like this are really, really important for medical training. So, Phil, I'm going to come and stand with my back to you so I can show the screen. And what we're having a look at here is you can see the nose in the body. Your nose doesn't go up, it goes straight back into your face. Now, if I tilt the skull back and you look right up the nose, can you see up in there little holes in the bone at the very top of the nose? Those holes are in the cribriform plate, and they are where the olfactory nerves, the smelling nerves, come through the bone into the nose. And that is where the molecules from the banana-flavoured jelly bean were getting to. And this is what Zahn's going to show you. So I've now turned the skull round. That's the back of the head. And he's going to look here. That's the nasal septum, the bone that divides the nose in two. Those holes go out the nostrils, and you can see the ridges of bone, the turbinates, inside. So that's where we're going to have a look now. So he's now looking upwards, and he's going to see, this is really, really difficult to do. We're going to see if we can get a view of the back of the nose, and there is a spectacular view. This is the bone, the nasal septum, that divides the nose in two. If you went out either of these holes, you'd come at his nostrils. There's a little nasal polyp there. Many of you will have these polyps, and they can cause problems. Zahn's already had one removed. And just up here, that is where those smell molecules are going in order that they integrate with your taste. So human smell is amazingly sophisticated. Humans can tell the difference between 5, maybe 6 different tastes, but we can detect the difference between more than 1 trillion different smells. And we're very good at it. Zahn, thanks for an amazing view of the back of your nose. Not easy to do that. Now just stay there, because actually get ready for the next view. Because by the time that you've integrated all those the taste chemical information from your mouth with the resistance to chewing from your jaw muscles, the vibrations of crunch going through the bones of your jaws with the smell, you build up an incredibly complex picture of everything you put in your mouth. And some scientists call the whole thing flavour. So there is even a debate in science about whether we just mean, when we say flavour, do we mean the whole package of experience, or do we just mean the smell? Now, what we want to now see is we've arrived at the moment of swallowing, and Zahn is going to now see if he can show us a live swallow. But to get this view, he's going to go down his nostril. Now, the entrance to the nostrils also guarded by hairs there, and Zahn's going to very carefully go directly back into his head, okay? So he's going to get to the back of his throat. This is the path. When you snort back snot, okay, this is the path that snot follows. So we're now going along the base of his right nostril. And it's very difficult, this. He's got to sort of slightly push it. We're now at the back of the throat. Now, that's a scar from when Zand had his tonsils, his adenoids out. And now Zand's going to look down his throat, and we're going to see if we can get a view. That's the back of the tongue, the furry back of the tongue there. And what we're looking at there, we've got a beautiful view of Zand's epiglottis there, and we're looking down his windpipe, his trachea. And those V-shaped folds of tissue there, those are the vocal cords. That's his larynx. So Zand, can you do a hum for us? And you can see he does a low hum. Do a high hum. Do a high hum. That's nice. And when you laugh, your vocal cords move in and out. Now, most of the time, of course, your vocal cords are apart. You spend most of your life breathing, not talking, laughing, or swallowing. But the thing you can't see here is the tube that the food must go down. It's folded flat, and it's just back there. It's behind the trachea. And so when you swallow, the most important thing is we don't get food down into the lungs. And that's what the epiglottis is going to do. Zand, thank you. That was a brilliant demonstration. Now, to understand just how hazardous swallowing is, I want to play a little game of Operation Epiglottis. Now, what the demo team have built here is a highly anatomically accurate model of Zand's esophagus, trachea, and epiglottis. So this is Zand's mouth, and you've got to imagine Zand's throat here. So Zand's sitting on the stairs. Zand's facing this way, okay? The trachea is in front of the esophagus. So I need a volunteer to come and play a game of Operation Epiglottis. Just here, come on down. Come on here. Now, what was your name?
Ethan.
Ethan, here you are. Now, you are going to operate Zand's epiglottis. Do you want to have a go? Just give it a pull. That's great. So you can see, you pull it this way, you block the trachea, and food can go down the esophagus. Release it, air can now go down the trachea. So we're going to play a game with 3 levels. Level 1 is just breathing and swallowing the odd bit of saliva. Okay, so we're going to breathe. So you want the air to go down the trachea, which it is doing very nicely, okay? And once in a while, I'll get you to swallow a ball of saliva, okay? So you ready? You want to send the saliva not into the lungs. You ready, Ethan? Okay, great. And the saliva's gone down into the stomach. Beautiful job. And now we're back to breathing. That can go down there. Now, Ethan, sometimes during a meal, we start breathing and talking and eating all at once. And sometimes we start laughing whilst we're eating. And I've got to say, Ethan, you're very good at this. Hold on. Don't be too good at this. So sometimes, Ethan, we do a load of laughing and we actually open our esophagus, with oh, Ethan! It is now game over, Ethan, and it's going to be game over for Dr. Zand pretty soon if we don't do something. Ethan, what do you want to do about the food trapped just above Dr. Zand's vocal cords here? Cough. Brilliant. Yes. Could we have on? Let's bring on the cough device and see if we can make it cough. Perfect. Now, Ethan, the cough device is, it's fair to say, a bit temperamental, so I'm gonna come and stand back. Ready? 3, 2, 1, go. Whoa! Very nice work. Ethan, bravo. Back to your seat. Great job. And if that hadn't worked, we could have done some abdominal thrusts and moved to the next level. But luckily, Ethan, you got us out of the hole. Brilliant, brilliant work. Now, Zand, we have prepared a very, very, very expensive, sophisticated meal for you.
That is what I've dressed up. I'm looking forward to it, Chris. Is it lobster thermidor? Is it lobster thermidor with cheese and chocolate?
It's more expensive than that, actually. This meal that we've prepared for Zand would be many, many hundreds of pounds. And it is, I would suggest, the most sophisticated meal you could possibly eat. Zand, what we have prepared is a capsule endoscope.
Oh, wow.
Now, Millie, thank you very much. In fact, I'll take the water. Now, Zand, show everyone what this is. So these are endoscopes we talked about as those fibre optic cameras. This is an endoscope that's just a little capsule. And it's incredible. It's got a camera at both ends. It's got a flashing light source, as you can see. It's got a battery inside it. And it has a radio transmitter. So when Zand eats it, we will get images from inside his body.
Swallows it, not eats it.
Swallows it. Yes, that's true. You shouldn't eat them. Yes, don't chew it. Don't chew it. Okay. Zand, have a big gulp of water. What you are now going to see is what we pre-recorded. Now, the pill is in your stomach, the pill endoscope.
Yeah.
Now, Zand, how did that pill get into your stomach? Did it just fall down by the force of gravity?
Well, yes, you sure?
No, it didn't. You know this. You're a doctor.
Okay, so my esophagus is smooth muscle, and those rings of smooth muscle squeezed it down through a process called peristalsis, so it got pushed
Very good,
down
very good.
into my
Right, so it's squeezed down there deliberately, and that means that we can eat in all kinds of situations, can't we? In space, upside down, and that is why, Zand, for the next course of your meal, I'm going to invite you to a very fine dining establishment with some quirks. Come with me, Zand. Zand, welcome to the Wheel of Doom.
What? Why is it called the Wheel of Doom?
I mean, it's the esophageal inversion device. I must stop calling it that. Now, stand on the the esophageal inversion device and strap yourself in. Great. Now, Zand, for the second course of your meal, we're going to turn you upside down and to get you to drink some cream. Are you ready? Invert the esophagus. Here he goes. Great work.
Okay.
Now you're upside down. How are you feeling?
Okay.
Not nice, is it? Now, see, have a big gulp of cream. Are you swallowing it? The cream is not pouring out your eyes, your nose, or your mouth.
I thought it would, but it hasn't.
Brilliant. Okay, let's flip him the right way up, and that has worked spectacularly well. You can see not only is the food squeezed down the esophagus, or up the esophagus in this case, very actively, but there are valves along the way that keep it in place. Zand, brilliant work, and I guess the team, can you just spin him around again and get him to finish the meal?
Chris!
Good luck. We'll see you later, Zand.
Stop it! No, Chris, I'm keeping turning!
To better understand the stomach, which is where that pill is now, I want you to welcome a very special guest. She is an anatomist. In fact, she's one of the authors of the current edition of the famous medical textbook, Gray's Anatomy. She's our official anatomist on Operation Ouch. And there is no one better to explain to us stomach anatomy and function that I can think of. Welcome, please, Professor Claire Smith. Claire, you brought some stuff with you, haven't you?
I have. So I've brought with me a pig stomach.
Okay, so this is a pig stomach that we're going to look at, and what's important is we have to say this is not for the squeamish, and we're going to... Can we actually, on three, can we all do a gross alert? You ready? Everyone just shout gross alert. 1, 2, 3, gross alert! So if you don't like looking at bits of anatomy, then look away now. Okay, Claire, show us.
So by quirk of nature, human stomachs and pig stomachs are very similar, but pig stomachs are quite a bit bigger than ours, and it's folded in the same way, so it's in a C shape.
Okay, can we pick it up?
That's the esophagus.
That's the esophagus.
Yeah. And it goes into an area really close to the heart.
So the stomach, when we talk about stomachs, we often think about, we sort of talk about the stomach and we mean the abdomen. The stomach, the organ, is near the heart?
Yeah, so it's sitting just underneath your lower ribs, so just about here, and heading towards the middle of the body. And it's got this dome shape on the top called the fundus, and this is where air sits. So this is where burps come from.
It's the burp factory?
Yeah, it's burp factory.
I love that, the fundus. Okay,
Fundus.
There you go. It was not me, it was my fundus.
Then we have the main body of the stomach, and this is where the process of digestion is going to be happening. And then it leads into the gatekeeper of the stomach, the pylorus, which controls food going from the stomach into the small intestines.
And that's a sphincter?
Yes.
A ring of muscle?
Yeah.
And that can clamp down tight, so the stomach can be a sort of sealed container?
Yeah.
Okay. What is the function of the stomach? Why don't we just have a tube going all the way through?
So it's more than just a bag. It's got a special arrangement of muscle. Throughout the rest of the tube, you've got circular muscle and longitudinal muscle, which helps push the food along. And in the stomach, you've got this extra oblique layer, and that helps with the mixing. And I'm going to cut into it and have a look. So do look away now if you are squeamish.
And all of the fibres of muscle run in different directions.
and that really helps with the mixing of the contents. What we're going to see now, just extend that down a little bit, is the lining of the stomach is thrown into lots of folds, and these folds are called rugae. And if I turn the stomach inside out a little bit, we can see those rugae really beautifully, and they're there to help increase the surface area. If we were to zoom in lots and lots onto the cells that we can see here, we would see cells that are making acid, we would see cells that are making enzymes, some that are making hormones, and some that are creating this mucus.
So the stomach is storing food, and I always think of it as like cleaning food with the fairly strong acid that's in there.
Yeah.
Does it have any connections to the rest of the body? Is it more intelligent than just a sort of muscular bag?
It is, and I thought you might ask that. So I've got another stomach.
Here we go. Okay.
I'm going to empty that one. So our stomach holds about 1.5 litres. It can be stretched more to be about 3 to 4 litres. So I've already made some vegetable soup, and I have already filled that into our stomach.
Okay.
If we want to lift the stomach out, we can see how big and how filled it is. So if you want to
let me
hold
try
that
and
there, and I'm
keep
going to
that
release the
attached.
clamps. Brilliant. And let's lift it up nice and high. So it is really,
Amazing.
really
So it's got
stretched
huge
and full.
capacity.
Yeah.
So this is now filled with far more vegetable soup than any of us would ever drink. What happens when you put this amount of food or fluid in the stomach?
If we have a look on the surface of the stomach, we can see these white and sometimes red wiggly lines. And these are the arteries, veins and nerves that supply the stomach. And one of the key things is these nerves are communicating from our brain and back up as well. So these are branches of a nerve called the vagus nerve, which starts in the brain, goes through our neck, through our thorax, and then goes to our stomach to tell our stomach to start those muscles moving and mixing. But when it gets really full, this nerve also says back up to the brain, I'm getting quite full.
Okay,
Please don't.
so the vagus nerve, those of you doing biology or if you become healthcare professionals, is one of those sort of key nerves in the body that you have to learn about. Okay, and amazing to see it shown there. Claire, that's an incredible demonstration. Thank you so much. Big round of applause for Professor Claire Smith. So it will then be time for food to leave the stomach. And Claire, remind me, where are we heading to next?
The food will now go into the duodenum, which is part of the small intestine.
The small intestine. It's not that small, that's how I remember it. The large intestine, very wide, small intestine, very, very long. And I'm going to show you where it is here. Oh. Now this is a perfect scale model of my gastrointestinal tract. You can see my lungs, trachea here, and I will pull out my esophagus, my stomach. Let's pull the colon off. We're going to leave the pancreas behind, the liver's there, and we're going to pull off my small intestine. Now, Claire, do you mind just holding the esophagus? In fact, give it to maybe a young person there.
Yeah.
And I'm going to go across here, and I'm going to pass this back to you. Do you mind holding this is not the nicest bit. I'm not going to say it. Hold the distal end of the colon. There we go. Beautiful work. And what you can see here, this pink tube, starting at the pyloric sphincter and going all the way to the ileocecal junction where it goes into the colon, the large intestine. This is the small intestine. It's 5 meters of our 7-meter journey tonight. And the mechanical bit of digestion is done now. What's going to happen in here is chemical digestion. Powerful enzymes secreted by the gut and by the pancreas are released into here, and they start chemically breaking down the food into its individual molecules that can then be absorbed. And why is it so long, do you think? What's important? Who thinks they know why is it so long? What do you think in the Christmas jumper?
I think that because it needs to make sure that all of the substances are properly processed and that they get all of the nutrients from them.
Very good. I love that. So everything's properly processed and you get all your nutrients. It's long because it needs to have a big surface area to absorb those nutrients. Brilliant answer. Let me show you what the actual surface area of the small intestine really is. because it's more than 50 square meters. So the back row have an exact scale model of the true internal surface area of this small intestine. And you can see it's enormous. It's as if this tube, instead of having a 3 centimetre diameter, had a 10 metre diameter. So the big question is, how do we get that much surface area into a tube with this small a diameter? And the answer we are about to reveal. Claire, can you say the word for us? What do we call them?
Microvilli.
The microvilli. The finger-like projections. And Dan, if you're ready to whip away, take it away now. So tiny finger-like projections in here, far too small to be seen with the naked eye. These increase the surface area and allow you to absorb all the breakdown products after your enzymes have gone to work on food. Brilliant, brilliant work, all of you there with your pink gloves on. And it's really important, like the stomach, you saw there's a rich set of nerves connecting the stomach back to the brain, sending signals back. The same is even more true of the small intestine. It's sending information back to your brain about the nutrients that were in the food so that you can then link that smell, the experience in your mouth with the actual reward you get from the food. Did it contain lots of useful sugars and fats and proteins? So information goes back, and it also says when you've had enough to eat. So fullness signals come from the small bowel. It's part of that sensory apparatus that helps you learn which foods you are disgusted by and which foods you desire. And by the time we get down here, almost all of the nutrients in food have been absorbed. The only thing you can't digest is the fibre in your food. And it's left here in a liquid slurry. There's hardly any nutrition left in it. It's just the fibre and a few digestive juices. And it's going to go into the colon. And here is the weird thing about fibre. As I say, we all know that fibre is good for us. Yes, we're constantly told to eat fibre. You don't produce an enzyme. Your bodies don't make an enzyme that can digest it. So in order to make use of it, we have to employ a few friends to give us a help. And those friends are some bugs that live in this bit of the colon. And in order to understand, I'll take that back from you, in order to understand just how those bugs work, I want to welcome an expert in our internal microbiome, an expert in microbiology. She's a medical doctor and an incredibly eminent scientist. Please welcome Professor Louise Kenny. Hi, Louise.
Hello, Chris.
I thought for a second you had turned into a goat. You brought a goat with you.
I have.
What's the goat's name?
The goat is called Juniper.
Juniper. Hi, Juniper. What are you up to? Do you want a
Well, let's give a little
bit of a
bit
scratch
to eat.
behind the ears? Do you want a beat?
There you go.
Do you want that?
I think she
No.
might want.
Juniper, hold on.
moment
Have
of
a bit of beet leaf. There you go.
There
How
we
you
go.
doing? How you doing? So, why have you brought a goat, Louise?
Well, goats are really interesting. They've got a very different digestive system to humans, and they demonstrate the importance of something called the microbiome perfectly. So you can see that Juniper is eating lots of plants.
Right.
Goats have a completely plant-based diet.
Juniper, look up here. We've got a picture of your gastrointestinal tract.
I don't think Juniper's interested in her gastrointestinal tract.
Oh, Juniper. Does Juniper's handler want to come out? Can we get your name?
Jenny.
Hi, Jenny. How you doing? So Juniper
Only eats plants.
makes a living out of eating all of that fibre that we're told we need to eat constantly. Talk me through her guts compared to ours.
So they're known as ruminants because how they eat is that they eat cellulose-based plants. They swallow them into the first part of their stomach and then regurgitate it. It's called chewing the cud, and they
Okay.
do that lots of times to help break up the cellulose.
So more mechanical breakdown
Exactly.
of food.
Yeah,
Okay.
and you can see Juniper doing that right now. She's sort of munching away on those greens.
She will swallow it down.
So
it
she
goes
swallows it
into
down,
the.
and it goes into this part of her stomach. So you can see that her foregut is huge.
And we've heard, many of us, that cows have 4 stomachs. Is that also the case with Juniper? She's got
So
different.
Juniper has 4 components to her stomach, including this really important one, the rumen,
Okay.
which is where they get their name, ruminants. So she'll swallow the cellulose, and within this big fermentation chamber are literally trillions and trillions of microbiota, so bacteria, fungus, and viruses, sitting in this fermentation chamber ready to break down the cellulose.
So do goats, I guess most of us would assume that herbivores make an enzyme to break down cellulose in the same way we make enzymes that break down proteins and fats and carbohydrates.
That's the key difference. They don't.
They don't.
Most of their digestion occurs because of these microbiota. Without them, they would not be able to break down their food and they'd actually die of starvation.
Really? So, and how much of their calories can a goat get from the fibre in plants?
About 70 to 80% of their energy comes from the microbiota digesting the cellulose in plants.
Right, they'll also get a bit of energy from some protein and fat in the
Exactly.
plants, but it's mainly the bugs digesting the cellulose. Okay.
Exactly.
Amazing. And they would, so just like us, they can't do it. Now, how much energy can we get from plants by contrast?
Well, a typical human, adult human, on a typical varied diet would get about 10%, so it's a huge difference.
Okay, so the bugs are doing the same basic function in juniper and us?
Exactly, just helping digest the food. It's just that in ruminants, they're mainly in the foregut, and in humans, they're mainly in the colon.
Okay, and what then do the bugs do for juniper? So when the bugs eat the fibre, what then happens?
Well, they break the cellulose down into far more simpler compounds that juniper can then absorb and extract energy from.
Okay.
So without that, she wouldn't be able to extract energy from her food, and she'd be a very, very thin goat.
Well, and she's definitely not.
She's not a thin goat.
She seems to be happy. Is Juniper happy? Okay, good. Goats and humans, do we have a similar microbiome?
We do, but your microbiome changes over the course of your life, and even over the course of the day, it's far from static.
Really? What kind of things change it?
It's a really dynamic environment, and it's changed mainly by the environment, and most particularly of all, food. Your diet is by far and away the most influential factor in determining your microbiome.
The soil, if you like, we put in that the bugs grow on.
The food that we eat, every gram of food has literally millions of bacteria within it.
Okay, that's amazing. I think we could do a very quiet round of applause for Juniper.
We don't want to scare her.
And for Juniper's helper. Thank you so much. You've got another demo here, Louise. Talk us through this.
I have. So we were talking about the difference between microbiome in goats and in humans. So these two tubes represent the microbiome of a human here on the left and a goat here on the right. And you can see that they're really different. Instantly, you can see that the microbiome of a goat is far more copious and diverse than it is in the human.
So they've got more bugs and different bugs.
Exactly. There are about 11,000 species of microbiota in the gut microbiome.
Is it just bacteria?
No, it's predominantly bacteria, but it also includes things like fungi and viruses. Whereas in the human microbiome, we're far less diverse. So far, we've counted about 3,000 types of bacteria.
But there are these commonalities, the blue bugs and the yellow bugs in this model.
So in humans, about 90% of our microbiome is made up of just two species of bacteria, bacteria called Firmicutes and Bacteroides. And you can see that exactly the same bacteria exist in goats.
Okay.
You'd also find them in other mammals as well. But then you have this big bunch of things that we don't have, and within this bunch of the microbiome are the critical bacteria that help break down the cellulose.
Do all humans have a similar microbiome if we got the bugs out of everyone in the room?
No, it's really diverse, even within species. So there are some similarities, but your microbiome changes over the course of the day, and it changes drastically over the course of your life. It's very simple at birth, and then it becomes very complex as you grow up. And then there's some evidence that towards the end of life, it becomes very simple again. But it's always changing. It's a constantly evolving environment.
And I've got an identical twin brother, and you will all know identical twins are genetically the same person. We come from a single sperm and a single egg. Here we are. Now, I'm guessing at this stage of our life, when we used to poo together, we did share quite a bit of our microbiome?
Probably, because not only are you pooing together, but you're living in very close proximity. And you're almost certainly sharing meals. You will be eating exactly the same thing in the same environment.
Right.
So your microbiome at this stage is likely very similar.
And these days, will Xander and I have the same microbiome? We haven't lived together for
Despite the fact that
20
you're
years.
genetically identical, there's no chance that your microbiome will be the same anymore because you don't live in the same house, you don't share the same meals. Your microbiome will look far more like your partners and your children, even your pets.
Really? So my kids I get, because I think I can say, they're not here, but I think even my kids would admit, children broadly younger than you, are not always the most hygienic. I mean, I know I swap microbiome with my kids because once every 6 months I get worm infections from them. So we must be eating a certain amount of faeces. So I get it with the kids, but what about the pets?
Well, do you have a dog?
No, we're a cat family through and through. We do not. Here we go. This is my cat, Winston, a long-haired Moggy.
It's a very handsome cat. It's very likely that you and Winston have a codependent microbiome. You probably share elements of your microbiome with Winston.
So that I don't understand, because cats kind of keep themselves to themselves. And he's my cat. My cat is not sleeping in bed with me. It's not like a dog. It's not licking my face.
What else does it lick, though?
Well, it spends a lot of time licking its own bum.
Yes. And does it lick anything else?
Well, I think we do have a video of Winston. Winston really likes... Winston will only drink from the kitchen tap. So now Louise has kind of pointed this out. I'm guessing it is possible that some bum bugs...
It's not possible, it's almost a certainty. So if Winston was licking his bum and then has licked your tap, and then you've had a glass of water, you will have bugs that have come from Winston's bum.
I'm going to get a second. I'm going to get a second tap. I mean, looking at this tap, it's not the cleanest tap anyway, is it?
No.
I think we're going to become a dog family from now on. And is that a bad thing, sharing a few bugs with our pets?
No, not at all. There's a lot of evidence that if you have pets, you have a much more diverse microbiome. And everything we know about the microbiome, and we're still learning, there's still so much to this science we don't understand. But what we do think is that a very diverse microbiome is associated with robust health. If you want to keep your microbiome healthy, you just need to have a healthy diet. So lots of fresh fruit and vegetables, whether they're cooked or raw. Things like whole grains, pulses, lentils. Okay. A nice varied diet will result in a really varied microbiome. No need for any fancy tests. And anyway, there's a very simple, cheap and readily available way to tell whether your microbiome's healthy.
Excuse me? Is farting a sign of good gut health?
Absolutely.
Really?
Farts are normal and they're very healthy.
OK, I'm absolutely delighted to hear that. Big round of applause for Louise Kenny. So, farts tell us a little bit about our bowel health, but it's also really important to look at our poop, because our poop can tell us a lot about how healthy we are. And it is worth glancing at it once in a while. And to have a look at some more solid evidence, it is time to call on the variable poo machine. Big round of applause. Now, obviously, I'm going to need a volunteer to run the poo machine. Everyone wants to run the poo machine. Now, I feel who... Now, you were... with the snow top, the grey top with the snowman on it, you were very quick with your hand. And a big round of applause. What's your name?
Ajay.
Ajay?
Yeah.
Great to meet you, Ajay. So what we have here is 4 model colons. Now, do you know what the main function of your colon is? It's got 2 functions. It's the home of your microbiome, the bugs we've been talking about with Louise, so they digest the fibre, but it also absorbs water from your poo. So we're going to make 3 different poos here. You're really wishing you hadn't had that hand up so quickly. So what we've got now, what are the elements? First of all, Ajay's going to make a healthy poo, OK? So what are the 2 things we need for a really healthy poo?
Vegetables.
Vegetables, great. So fibre, fresh fruit, vegetables, pulses, things like lentils. Really good stuff. So this is what we've got, some fibre in this bowl, and I want you to pour some water. Let's add a bit more fibre to the bowl. Great stuff. A bit more fibre, great. And now we're going to pour in quite a bit of water. Pour in that thing of water. And what I want you to do, Ajay, is to mould a nice poo shape out of the fibre. Great stuff. Now, this is what would be happening in your gut. The fibre's all that's left in your colon. And what would happen in your colon is the gut would absorb the water. So you're left with a moist but fairly firm sausage at the end of the gut. So you're going to sit down on the toilet. It's going to make its way into the rectum, and you can see how easy this is to pass into the toilet below. Are you ready? Okay, just go. And it passes easily. You relax, and it goes into the toilet. Now, if you don't eat lots of fibre, OK, what arrives at the rectum, which is the storage bit at the end of your gut, is more like this, OK? It's just a dried out clump of bugs, so you can mould that a little bit. There might be a little bit of fibre in it. And if you don't drink enough water, it will end up being really dry. The colon will suck all the water out of it. So these are the elements for a healthy, easy to pass poo. Fibre and water is important. And what we're going to see here, so Ej, let's come along here and see if you can get it to go down to the toilet. Now, we may have to give a bit of a hand. Can everyone go straight? You've all been, remember when you're very little and you get constipated, can everyone on the count of 3 strain together? 1, 2, 3. It's hold on. I mean, sometimes in hospital you have to give people a hand with this. So there we go. You can eventually push it out. But poos should obviously not be this hard to push out. And if you pass lots of dry, hard poos like this, it can damage the lining of the anus. You can get fissures, hemorrhoids. You can ask your grown-ups about these things after the lectures. Almost all grown-ups have experience of these things. So fibre and water, really important for having an easy poo. You shouldn't have to do all that straining and pushing. So, brilliant work. We've had a healthy poo, a constipated poo. Now time for some diarrhoea. Are you ready? So diarrhoea, maybe we've eaten some fibre, maybe we haven't. It doesn't matter. Pour the water into there and bring it over here. There are lots of things that cause diarrhoea, but the common bugs that do it either stop your colon absorbing water, or sometimes they actually make your colon produce water, and so they make your poo, your stool, really, really runny. So this would be a bacteria like cholera. Cholera makes water go into your stool, and it can be really, really dangerous because you dehydrate very quickly. So pour the cholera poo through there, and in this case, of course, Ej, we didn't even make it to the toilet. So we've all been there, a close call, but great work. So, Ej, you've been a brilliant sport. Thank you so much for demonstrating. There is a final scenario I want to demonstrate. You will remember that what should arrive at the beginning of the colon from the small intestine should really just be your fibre. Almost all of the protein and the fat and the sugar, the nutrients, have been absorbed into the body. So the fibre goes in there. But there are some infections which damage the villi, the finger-like projections in the small intestine, infections like giardiasis. When those villi go away, the surface area shrinks and you're left not being able to absorb your sugar, salt and protein. So they go into the large bowel. And Louise, what then happens when it gets into the colon, Louise?
Well, the bacteria in the colon don't normally see sugar and fat. And when they do, really bad things happen.
Really? OK.
Very bad.
And they're quite good at eating that stuff. It's an easier meal for them.
They absolutely love it, but it has some quite disastrous consequences for the host.
So what I'm going to do now in our final colon is put in a little bit of sugar and fat and protein into this gut, because the villi here have been flattened and this gut is malabsorbing. It hasn't absorbed them. And so we're going to see what happens. Are you ready? OK. Oh! There we go. Yep. And Louise will confirm this, that is why we call conditions like giardiasis two-bucket diseases, because you need a bucket at both ends to deal with them. Norovirus is another one. Now, that poo that you get when you're not absorbing your nutrients, it's foul and it floats because it's full of fat. And a healthy poo contains almost no real nutrients at all. Your gut, your digestive tract, is incredibly good at absorbing everything you need from your food. And what happens to those nutrients, their destiny, that is the subject of my next lecture. Thank you very much.